Hello, Kai. So it looks like you were being asked to find a volume of rotation of the curve y equals sine x on the interval 0 to pi. So let's actually indicate that interval on our graph, 0 to pi. And we can see that as this is rotated about the x-axis, we'll kind of sweep out a volume that looks approximately like this. Forgive my imperfect drawing skills. And so how will we find the volume of rotation? So if you've seen this in class, hopefully you've encountered the method of washers or disks. And I want you to take a moment and try to think about how we can slice this object up into disks. Since we are rotating about the x-axis, we're going to want to slice vertically. So let's actually look at what happens here. For example, I'll take a representative slice here. This has height 1. And notice as we rotate about the x-axis, we sweep out a circle of radius 1. More generally, I can indicate my circles as a function of position x. At a position x, a generic position x, our radius value for the circle will be sine x, since that's our y value here. So r is equal to sine x. And so each circle will have area as a function of x equal to pi times sine x squared. How does this help us get our volume? Well, integration is all about adding up infinitesimal quantities. So what I can now say is that each of those circles, in fact, has an infinitesimal volume given by its area times its thickness. And its thickness is infinitesimal dx. And so finally, to get our total volume, we will integrate this infinitesimal thickness. Let's plug in for a of x, namely pi times sine of x squared. And then we will have dx. Last step in setting up our integral is to determine our bounds. And of course, that was kind of given to us in the beginning of the problem. We'll start at x equals 0 right here and go up to x equals pi. And so there we have it. This is our integral. And now at this point, you can go back into your toolkit for integration, specifically for trigonometric integrals, and evaluate this. Hope this was helpful, and have a great day.